My goal today is to do nothing more than convince you that you do not always have to have the Gregorian calendar in your application. You can actually use calendars for other cultures and other times, actually, in your application. So we're going to do a little brief history of time. Yeah, I guess so. Okay, so from the beginning of time, calendars were generally lunar, and they were observational based, right? So somebody look at the sky, they go, hey, look, it's a new moon. Must be a new month. And they pop the month over a day. They would start the dates at 1, and they would continue on with their calendar making. The problem with a observational calendar, however, is that somebody has to decide that it's actually a new month or a new year. And if it's not a new month or a new year, then how long will it be till the next one, right? And months don't have an integral number of days involved with them, and neither do years. Years are not an integral number of days long. They're fractional days long. So somebody has to figure out, how do I intercalate? How do I throw days in so I can sync up? Because it's very important for a lunar calendar to sync up so that the first day starts at a new moon, and the middle of the month is a full moon, and the end of the month is your new moon, or the moon where it's not visible. And so, of course, that fell to a very important person, a Roman senator, or somebody like that, right? So you can imagine what happens when a Roman senator or somebody like that becomes involved with actually setting things like intercalation for your calendar, right? It's the same thing that would happen if a US senator was responsible for that. It would turn into a disaster, and it did very quickly. It devolved to the point where by the time Julius Caesar came along, he said nobody outside of Rome knows what the day is, and it's worse than that. We're actually having harvest calendar or harvest festivals in the middle of June. So the problem was, he knew he needed to get humans out of the picture. So he wanted to make a computational calendar, and that's what they set out to do. A computational calendar would have lots of benefits over the ones where people are making decisions. One, there's no humans involved. Two, they're predictive. You can actually now look to the future. Hey, when's it going to be spring next year? How many days is that going to be? Things like that would have gone. But it does require some math chops, right? Well, it didn't seem like it would require that much math chops. But the problem with Rome is that they didn't have a 0 in their math, right? And so you can't do modulo arithmetic without a 0, and it threw everyone off. And in fact, for the first 36 years of the Julian calendar, they actually did it wrong. They actually did it, rather than every 4 years, they did it every 3, and it was all goofed up. So the thing that I want to get through today is that there's lots of different calendars that are available to you. There are 4 different types of calendars. There's literally thousands that occurred. But there's 4 different kinds of calendars. There's a lunar calendar, a solar calendar, what's called a lunar solar calendar, and then what's called a counting calendar. And a lunar calendar simply wants to measure the moon. So, all you guys out here, much, much smarter than ancient Babylonians. How long is a lunar month? Synodic lunar month, which is the mean value of a lunar month. Yes? 28, 29. Oh, man. Okay, so the ancient Babylonians said 29.53094 days. Divide that by pi. And that actually was a number in base 60 arithmetic, but it was only 0.6 of a second from being right, which is amazing. And they did that in 600 BC. You guys didn't do very well. Okay, so, but they're about 29.5 days long a month. And so if you have a lunar calendar, you go 30, 29, 30, 29. And by the end, you're close. You might have to intercalate once in a while. Throw a leap day in 11 out of every 30 years to prevent lunar drift. And you've kind of got your lunar calendar figured out. And they actually had that done by 400 or 500 years before Christ. Now, the seasons blow through this calendar, though, because 12 times the 12 months at 29.5 days does not add up to 365.25. So while your lunar calendar matches up with the lunar cycle very well, it does not do anything for solar cycles. So that really bothered Julius Caesar because he ended up with situations like harvest festivals in June and large armies trapped in foreign countries in the winter because they didn't know what the day was going to be. And so the tropical year, which everyone knows is 365.25 days, is actually wrong again. The Gregorian reform came along 1,500 years after Julius Caesar, set it at 365.2425 days, and the modern value is something like 365 by 24219. But the point is that they had a pretty good idea of how long a year was. So lunar phases blow through a solar year, and so you can't manage lunar cycles that way either. Lunisolar calendars are the coolest ones. Now, this is the Hebrew calendar. This is Guy Metan. He figured out that 19 years of solar years equals 235 lunations. And so they actually add up to the same number of days. And so with that information, you can actually figure out how to intercalate without having a human being doing it. You can actually do a version of that with computationally. The last kind of calendar actually is the Mayan long count calendar, and you guys all are familiar with the 1300 on the end of the world thing. And that was actually a counting calendar. It's the same kind of calendar that's in an operating system. So what I wanted to get to was the JavaScript library, and I'll go through this quickly. It's very, very simple. I want to represent dates from multiple calendars. I want to convert to them. So I have a counting calendar called the astronomical Julian date. Like every other counting calendar, it has a epoch, which, like for JavaScript, it's January 1st, 1970, and at UTC midnight. In this case, the epoch for the astronomical Julian date is 4713 years BCE at noon on January 1st on the Julian calendar. It couldn't be more weird. The reason that was picked is because the astronomical Julian date, if you look it up, is actually the lingua franca of calendar systems. And if you look hard enough on the web, you will find from the Islamic calendars, from the Hebrew calendars, from the Gregorian and Julian calendars, conversions to and from that format. So if you make this your format of choice in the middle, then it's easy to convert to that calendar format. And what you want is a subsystem out here that can actually do something like this. Take a date in the fall on the Gregorian calendar, convert it to a framework date, and then from the framework date, convert it to Hebrew, right? So if this thing actually ran, it would say that, September 4th of the year 2013 is the same as Tishrei 01, 5774 on the Hebrew calendar. That is, I got it. That is New Year's Day in their calendar. So on the framework, one thing I do want to go through, stuff you thought was true turned out not to be true. Every year is 12 months. Not true. On a Lunisolar calendar, there are 13-month years. That's how they intercalate to keep the lunar cycles intact. Hours divided into minutes and seconds. Wrong. On a Hebrew calendar, you don't have hours, minutes, and seconds. You have hours and parts. 1,080 parts instead of minutes and seconds. 6 p.m. comes after 5 p.m. Wrong again. On the Hebrew calendar, 6 p.m. starts the day. 5 p.m. nearly ends the day. Years start with the first month. That's a good one. So, and if I hit run here, you'll see that the very first month of the year is 7 on the Hebrew calendar. And you can convert the date without knowing the time of day. That's also wrong because you need to know the time of day, and I'll show you that one here. If I look at, this is the Hebrew calendar. We are now in day 12 of ER that month. If I switch this to the Gregorian calendar, so this is just a small, really fast little thing that I used, you'll see that the days actually start at midnight on the Gregorian calendar, but on the Hebrew calendar, they start at 6 p.m. So if I click on a day here, and then switch to the Gregorian calendar, I'm now in yesterday, right? So things like that go on, and your framework needs to be able to handle it. All right. One last thing that I do, I'll go ahead and show you, and then I'll get off the stage. Shakespeare and Cervantes both died on the very same date. That date was April 23rd of the year 1616. The problem was they died in different places. Cervantes died in Spain, and Shakespeare died in England. England was on the Julian calendar at the time, and Spain was on the Gregorian calendar, and they actually died 10 days apart, even though they died on the same day. So, like I said, this the framework that got put together here, I was going to show some code, but I won't right now. It's all out on GitHub, and you can go ahead and take a look at it there.